Well, Mike Randall is here joining us with the wonders of physics. You brought a laser with us. Most of people think of laser. You know, most people think of a laser when you think of a concert, or maybe when you're trying to break into a museum and you're going over and under them. But what do you have here?
We use lasers everywhere, but what I'm going to demonstrate today is an example of kind of the weirdness of the quantum weirdness of light and other things.
Okay.
So what we have here is we have a laser beam, and we've got a screen over here. In between, we've got just a single slit. It's a little narrow slit, about the width of a human hair. Now, normally, you know, a lot of times, people for over centuries have gone back and forth. Is light particles? Are they waves? So
I debate that with my friends all the time.
I'm sure you do. Oh, after about maybe a couple beers, maybe, then it's like it goes that direction. So if it's particles, you'd expect them, think like BBs, shooting BBs from a gun toward a little slit. You'd expect to see a little slit-shaped pattern show on the back, the back wall, right? That seems reasonable. And if you were shooting something the size of BBs, that's exactly what you'd get.
Okay.
But when you get down into the really tiny realm of light and other particles, something very strange happens. It actually sets up a wave pattern. So it's called diffraction. It's where if two waves come together, sometimes they reinforce, sometimes they cancel out. So instead of seeing a single slit, you get what you see here. Now, can you folks on the audience see that? It's
yeah, they can see that. Yep.
It's always fun to do light demos in a brightly lit studio, which is why I have kind of this crude shade here. But you see a pattern of light and dark. That is typical of what happens with waves.
Okay.
So scientists actually went from Newton's time, where they thought it was particles, and they discovered, ooh, look at what liquid's doing. It's creating this interference pattern. It creates waves. And that was with a single slit. Let's see if we can do it with a double slit. So you see even more little patterns there. I don't know how tightly we can focus in on that.
Zoom it on in, Kevin.
Yeah. So the weird thing is, though, so you say, oh, great, light's a wave. It will interfere with itself. Fantastic. Then the scientist says, what happens if you just shoot like one little photon at a time? A photon's a single little, wave packet of light energy. We should go back to seeing either just like the BBs. You should see like a couple of patterns behind each slit. It doesn't work that way.
Ah.
If you do it long enough, you start building a pattern, it builds up that same pattern, even though they're only going through one at a time. How can something interfere with itself? And that's really was a real stumper for scientists. What they say now is that it kind of, when the light particle, and it's not just light, it could be other particles like electrons, atoms, even molecules. They actually, as they're traveling through space, until you measure them, they exist as a probability. They can be in any number of places. So the pattern you see on the screen is, where's it likely to hit? Now, when it hits your detector, or like a piece of film or something, you'll see little individual dots. But over time, as they build up, you'll see that pattern emerge.
Okay.
So it's like, so think of it this way: that little photon of light is actually going through both slits at the same time, which is bizarre, to say the least. And it's also going through neither slit at the same time. I know, Sunday morning, how can we do this to us? But our world gets very weird at the quantum level. And it's like I said, it's not just about light. It can be about things that we normally think of as being solid matter, like electrons and molecules and stuff. No, they actually exist as a probability wave, if they will, and they can interfere with each other, and you get these very strange patterns that will emerge. So our world is very strange, way stranger than I am, especially on a Sunday morning. I know, it's hard to believe. Anyway, by the way, the reason I brought this out, I'm going to plug something here. There's a new science museum coming to Madison.
Yes, we are very excited about that.
Yes, the Madison Science Museum. It's coming to. They're planning on opening in late October, or latter part of October, and we are now. The Wonders of Physics is building a dozen laser-related science exhibits.
Very cool.
This will be one of them, so you can come out and play with this.
Hands-on, too, so even better.
In a much darker room, so you can actually see the patterns if you come to the museum, right? We're also going to have, later this month, on August 1st, Saturday, August 1st, at the Wisconsin Institutes for Discovery, we'll also be bringing a few of those demos there, so you can also come there and interact with them directly. That'll be a Saturday morning, August 1st, between 10 and noon.
All right, fantastic. Thank you very much, Mike. This was mind-blowing, and I'm going to go home and think a lot about this today. We'll be right back.